Hey guys, today we are going to take a look at the vertex form of a quadratic. So the first thing we're going to do is we're going to take a look at the basic quadratic relation y equals x squared. So we've got our table of values right here, which we've seen 100 times already in this unit. Okay, and we've got the graph right here. What we're going to look at is what we call the step pattern. This is just the easiest, fastest way to graph or figure out the equation of a vertex form. Okay, so first of all, for this one, the vertex, which is right there, is just at 0, 0. Okay, from this opens up, and we're going to look at the step pattern here, which it's got in red, green, and blue. So the first one, which is in red, we start from the vertex, we go over 1. You always go over 1 for the step pattern. You never go over anything else. Always left to right, always by 1. But then, in this case, we go up exactly 1 square. So over 1, up 1. Okay? From there, so now we're at this point right here. Okay? And we're going to go over 1. This time we're going to go up 3. So up 3. My color coordination on these things has never worked out so well before. And finally we go over 1 and we go up 5. So the step pattern for this one is 1, 3, 5. So next we are going to consider the relation y equals 2x minus 3 squared plus 2. So let's see. So first of all, we're going to sub in what we have here. And so we get, I'll just finish the table of values here for you. So if x was equal to 3, we would have 2. If x was equal to 4, we would have 4. And if x was equal to 5, we would have 10. And if you don't believe me, you're more than welcome to punch them into a calculator and find out. So if we graph this using a table of values, we would get, hold on, I need to be able to see it. There we go. So we would get 3, 2, which is right there. We would get 4, 4, which is right there. And we get that one there. We get 1, 10. And something that people often get concerned about these, or with these questions, is those are the only 5 points that will fit on the graph. What do I do with the other points? Well, you can't do anything with them. They don't fit on the graph, so don't worry about it. Okay, we got 5 points. That's plenty. And we draw our perfectly smooth curve. Look at that. I could totally be an art teacher. Anyway, so there we go. So there's our parabola. So this time, what's the vertex? Well, the vertex would be 3, 2. Over 3, up 2. And that puts us right at that point right there. Which way does it open? Well, this one opens up. And what is the step pattern? So this time it's a little different. So first we're going to go over 1. We go up. Oh, that was supposed to be in a different color. Over 1. And we went up 2. Okay, from that point we'll go over 1 and we go up 6. And from there it doesn't fit, so you can just take my word for it. We would go over 1 and up 10. Okay? And you can see that from here. So let's see, what was that? That was at 4, 4. So we were right here, right there. And we went up 6. Well, that was all that fit. So whatever. Anyway, that's what the step pattern is in this case. It's 2, 6, 10. Okay? So I guess I can write that down here. I can say 2, 6, 10. And our step pattern is always just going to be 3 numbers like this. So the last one was 1, 3, 5. This one was 2, 6, 10. So how do we do this? Well, if we go back and we look at this, we say, well, what did I take? This untransformed version, I had 1, 3, 5. It's always going to start with 1, 3, 5. But this guy right here had a 2 right here. And what you do is you're just going to multiply the step pattern by that number. So instead of 1, 3, 5, it became 2, 6, 10. If that number was 3, instead of 1, 3, 5, it would be 3, 9, 15. Okay? So you just multiply 1, 3, 5, multiply all three of those numbers by that number. So, to summarize here, how to graph using step method, what you're going to do is you're always going to identify and plot the vertex. So start by plotting the vertex, which we've already learned is just h and k using that vertex form. From there, we're going to determine the step pattern. Okay, which, like I say, it's just going to be 1, 3, 5. This one goes to 7. You could go forever, but I mean, how many points do you need to draw on your parabola, right? So 1, 3, 5 is fine. That'll give you, that's enough for 5 points, which is more than, like, that's plenty. That's fine. You don't need more than 5 points to plot your parabola. Sometimes we only get 3. Better with 5, but it doesn't matter. Okay. So we're going to plot those points. Plot the step points. Okay, over 1. Up or down, 1a, 3a, whatever. Okay, remember you go down if a is negative. Okay, that's the only difference. Okay, and then what we're going to do is we're going to reflect, because of course usually we can only get 3 points from that way. We reflect those points across the axis of symmetry. Which gives us a lovely parabola. And finally, we draw a smooth curve connecting the dots. Okay? And do your best to make it smooth. It doesn't have to be perfect. Mine never are even close to perfect. As long as you try to make them perfect, that's all that really matters. Okay? So, here we got a couple examples here. So first of all, we're going to graph it without using a table of values, because that's the idea here. You don't want to have to use table of values. Table of values suck. They take forever. This is a much faster, much more efficient way to do it. So we take our first one here, and we always start by just saying, what is the vertex? Well, remember your vertex comes from this number and this number. Remember the wacko-bracko rule, or wacky-bracky rule, however you say it. Okay, the 1, it's a 1. But it said +1, it's inside the brackets, so we have to change it to a negative. The 6 is not in brackets though, so we can just leave that how it is. So we start with that. We say, what's our direction of opening? Well, it's got a negative, so it's going to open down this time. Okay? And then we just say, what's 135 times the number in front? So in this case, we are multiplying by the -3. -3, -3, -3. So we get -9. Well, -3, that one's already done. And then -15. There we go. And now we plot it. So, start with -1, 6. I'll start at the vertex. So we go -1. Wait, what was it? -1? Yeah, sorry. -1, 6. So that is right there. So there's our first one. So now our step pattern was -3, -9, -15. So you go over 1, always over 1, down 3, puts us right there. Over 1, down 9, puts us right there. Don't have any room to do the next point, so I've got 3 points, that's plenty. And we're going to reflect it in the axis of symmetry. If you need to draw the axis of symmetry, draw the axis of symmetry. Most people don't, but don't worry, but do it. It's better to get it right by doing an extra step, right? And there we go. We got our 5 points. So this one, so sorry, I should explain how I did those. Okay, this point was 1 from the axis of symmetry. This one's 1 from the axis of symmetry. This one was 2. That one's 2. You just reflect it in that axis. And from there, we just draw our perfectly smooth curve. Yeah, that one's not too bad. And that's it. You do have to label your equation, of course. So this will be y equals -3 x plus 1 squared plus 6. And there we go. Okay. And that's it. Okay. So let's do one more. This one's a little bit trickier, but it's still not too bad. So you always start with the vertex. Again, +3, not -3, +2. Okay, because remember that negative there, we are going to change to a positive. Okay, this one opens up because the number right there in front is positive. And this time we're multiplying by 1/2, which obviously multiplying by 1/2 is not nearly as fun, but okay. Now, whoops, why am I multiplying by 1/3? 1/2. Okay, so 3 times 1/2, typically we'd write that as 3/2. You could write it as a mixed number so that it's a little easier and say, oh, well, it's 1.5. But you know what? To be honest with you, the easiest way when you're dealing with these things is to use decimals. I know I don't normally like decimals, but in the world of graphing, decimals are easier than fractions typically. So I will forgive the decimals here because that's kind of how I do it. It's not kind of how I do it, it's exactly how I do it. So anyway, there's our vertex at 3, 2. We're going to go over 1, up 1/2. I'm going to zoom right in so that I can make sure it's nice and accurate. There it is. Then we go over 1 and up 1.5, which takes us right there. And over 1 and up 2.5, or 2.5, which takes us there. Again, you certainly don't have to draw the axis of symmetry, but I frequently do. There it is. We reflect that, we reflect that, we reflect that. There we go. This one we got lots of points. It should make it nice and easy to do a nice smooth curve. And there we go. And that's it. And then all we have to do is write down the equation to get those communication marks. So y equals 1/2 x minus 3. This is a little sloppy, but that doesn't matter. Squared plus 2. Oops, plus 2. There we go. It would be, yeah, whatever. And there we go. So that's all there is to it. Okay. So let's just fill out a little chart here. This one we can, this is just same idea, but we'll just sort of the Coles notes without the actual graphing. So this one, the vertex is just -4. And then we had 64, okay? -4 from that +4, and then 64 right there. Step pattern, we start with 1, 3, 5. We multiply by 4. So 1 times 4 is 4. 3 times 4 is 12. And 5 times 4 is 20. It's a good thing we're not graphing that one. I would have a hard time fitting that on a chart. It's all positive. Let me double check that I'm right about that. It is all positive, so this one's going to open up. Okay? And then just for fun, we're going to do one where we go backwards. So y equals, it opens down, it said, so we got a negative number. If you're going backwards, the easiest way to do it is to look at that first number in the step pattern. The first number is always just your a value, so it's a -1. We're not going to write the 1 though, because that's silly. And then we're going to say x, and then we go, well, it's a +20, so we want a -20 because it's in the brackets. And then -10. And that's it. So, until next time, go Sabres.